Hi there, this is Imaneo. Welcome to my channel. So as you remember, we are implementing a game using Flutter and Plain Game Engine, and it is called Flappy Dash. In today's episode, we are going to continue the multiplayer feature that we are implementing. And yeah, so as you remember, this is the UI that we implemented for the multiplayer. This is the homepage, and when you click on the multiplayer, you see this screen, and here you see all the players that are joined in the lobby. And after a countdown, the game starts. And also we have some backend code, so I just explained the backend code that we implemented using Nakama in the previous episode. And yeah, so first of all, we need to implement the function that returns the waiting match. So as you remember, we have a concept called waiting match. So each match has 3 phases. So the first one is waiting, the second one is running, and after that it is finished. And first of all, we need to get the waiting match when you click on the multiplayer button, and then we can join the waiting match using the ID that we retrieve from the backend, and then we can listen to the events, we can see other players, and so on and so forth. So as you remember, in the main function we have get waiting match RPC. So this is a function that we defined in our backend, and it just returns the waiting match, the first waiting match that we have in the backend. And we registered it with this name. So now we are able to call this function using our client, using our Nakama client that we have, and it just returns the match ID that we have as a waiting match. So let's copy it and let's open the Nakama data source that we have. And here I'm going to define a future of a string get waiting match. And we don't need anything as a parameter. And here we can say client.rpc or something like that. Yes. So this is the function that allows you to call some custom functions in the backend. So for example, it wants the session and then it wants the ID. So ID is this one, and session is something like this current session. And we get a match ID. And match ID is something like a string that is nullable, so we are going to throw an exception when it is null. Okay, and after that we can return the match ID that is not null. Okay, so now we should expose this function using a repository that I'm going to create it. In the repositories, I'm gonna create a new repository called multiplayer repository dot. Okay, and here we have a future of a string for get waiting match ID, and we have the Nakama data source, and we just proxy the function that we already created. Yeah, that's it. And then we need to register this repository in the service locator that we have. As you remember, we have service locator here. Let's copy paste this code and multiplayer repository, and we just need to have the Nakama data source for now. And yeah, so that's it. Now we need to create a qubit to handle the homepage or something like that. Then we need to call the get waiting match ID function when you click on the multiplayer button. Okay, so let's create the qubit that we want to have. I'm gonna call it home qubit, and let's create the qubit classes using equatable. And yeah, so I've prepared some codes to copy paste, and then I'm gonna explain you. It is this one, this is the state, and we have the code for the qubit itself. It is here. Yeah, so let's take a look at the state. We have 3 properties. The first one is a boolean, and it is true when we are loading the match, the waiting match, and it is false when we are not loading. And we have the error. So when an error happened, we just show an error to user that we couldn't find the match ID or something like that. And then we have a string to open the multiplayer lobby page. So this is for when we got the waiting ID from the backend and we just need to open the lobby page. And in the qubit, we only have a single function, so it is this one. By the way, we got the multiplayer repository in the constructor, so it is injected. And here it is the logic. We say that if it is already loading, please do nothing. And if it is not loading, please set the flag to true. So we show the progress indicator here. And then we try to get the waiting match ID using the repository that we have. And after that, we just set the loading to false because it is loaded. And then we set the match ID to the open multiplayer lobby property. And after that, we make it empty. It is because we don't want to open the lobby page twice. We just need to listen it once, and it works like a side effect or something like that. It just notifies the listener to open this page, and after that, it is empty. And then whenever an error happens, we just set the loading to false and we show something as error. So we have the same thing that we have here. We just fill the error and then we make it empty to just listen it once in the page that we are listening to it. And now we can do something in the home page. So let me find it. Home page. Yeah, so I can wrap it with the block builder, I think. Let's see, we have show loading. So as you see, when it is true, we show the loading, and when it is false, we hide the loading. So now we can wrap everything with the block consumer, and here we have home qubit. Yeah, the point is that using block consumer, we have the builder and also the listener. We have both of them at once. And here we can say if state.loading is true, please show the loading here. And if we have the state.open multiplayer lobby, if it is not empty, open the lobby. So to open the lobby page, let me find it in the app routes. It's here. So we need to accept the match ID here, and it's in the constructor. Okay, now we need to parse the property to pass it here from the route. As you see here, we have the match ID. I think we need to have a slash here, and we can say match ID is state.path parameters, this one. Okay, now we get the match ID using the parameter that we have here in the URL, and then we pass it to the lobby page. And now we are able to say context.go /lobby /state. This one, that is the match ID. And also let's show the error. If we have state.error is not empty. And to show an error, I'm gonna use toastification package. So as you know, we have a package called toastification, and it just shows some toast messages on the screen. And I'm going to import it to the project that we have, and then we can use it to show the errors. Toastification, and yeah. And to do that, we can just say toastification.show, and the context is context that we have, and the error is this one. And then we have type. For example, if you say error, it shows it in red style, so it seems like an error. And then we have the duration. By the way, I'm going to create an extension method for this to have it on context. I'm going to create a directory called extensions, and here we have build context extension. And I will create an extension on build context, and then we have show error. We just need to import the toastification. And yeah, so instead of the context, we pass this because we are in the build context. And yeah, so now we can just use this function instead of calling toastification directly. So let's find our home page, and instead of this one, we can say context.show toast error. And as a message, I'm going to pass this one. Okay, now we can reuse this function in the code base, and now we have to provide the qubit that we created here because we haven't provided it somewhere else in the code. So I'm going to create a new homepage. So this is the code that I just pasted here. And we have a block provider here. We just provide the multiplayer repository to the home qubit constructor. So this is the dependency injection that we have. And then we need to rename this part of code that we already have to homepage content. And by the way, we can make it private because we don't want to expose this one directly to other components of the game. And yeah, so now this page, this part of the code has access to the qubit that we provided here. So let me run the game to see what happens. And in the qubit, I'm gonna create some logs to see what is happening. Function started, function loaded, and function error with E. I think we are not calling this function, so let me add it to the button that we have. Yes, it's here. So instead of opening the lobby page, we are going to call the qubit.onMultiplayer button pressed. So this way we run this method and then we open the lobby page here when everything is successful. So let me run it again, and if you click, yeah, we have an error. It says that not found, and we have a problem with the connection. So the point is that we need to run the server locally, and we need to use the local IP addresses to allow the app to connect to the local instance that we have. So in the Nakama data source, I'm gonna change the host to localhost. So if it is in debug mode, we will use localhost. Otherwise, it is api.flappydash.com. And also for the ports, we are using another port for the debug mode because it is in 8 range, and in the production it is in 7 range. And also we don't have the SSL in the debug mode. So let's say that we don't want to have the SSL in debug mode. And yeah, so I think now we are ready to connect to the Nakama that we have. And also here we need to run locally. Yeah, so now the game is running, and now I think we are able to run it again and just click on the button. Yeah, so the function has loaded the match ID. So this is the waiting match that we have in the backend. And now we can just connect to the match and listen to the events. Okay, now we are ready to get connected to the backend to retrieve the events that we have from the match. And I just copy pasted some boilerplate code here. For example, for the playing state, we have these 3 items in our enum: idle, playing, and died. And we have match phase, which is waiting for players, running, and finished. So these are the state structure that we defined in the backend. I just copy pasted the Dart codes here. And we have the player state. So we have these properties here: is in lobby, last known X, score, and playing state. And we have the from JSON method. And also we have the match state. So this is the state that we have for the match. We have match initialized at, which is a date time. And this is the timestamp when the match is initialized. And then we have match runs at, which is a timestamp. And we need to create the countdown based on this value. So we need to compare the date time.now and the match runs at, and then we can show the seconds that are remaining to the match runs at every second. So it's gonna use this one. And then we have match finishes at, so this is for when we are inside the game. And we have current phase, and it changes from the waiting for players to running after a short time. And then we have a list of presences, so this is the online players that are connected to the game. And we have a map of player ID to the player state that stores the player state. So when someone reconnects to the game, we can keep the state that we have for the players. And yeah, so also we have match event. So these are the events that we defined in the backend. And as you see, for example, we have match welcome event. So it extends this sealed class. And we have match waiting time increased. So this is for when we have an increased time for the lobby. For example, the backend decides to increase the time because the players are not enough to start the game. And we have match presences updated. So this is for when someone is joined, someone is left, and so on and so forth. and we have match started event. So for example, when we have this event, we need to show the game page because the phase is changed to the running and we need to play the game. And then we have match finished. So this is called whenever the game is finished. And also we have some events for the player actions. For example, when a player jumped, when a player started the game, when a player dies, and other things. But for now, I think we just need to listen to these events. And yeah, so in the base class, we have the state and the sender. So each event can be sent from the backend itself or also the other players. So it's a nullable field and we have the state. So in all events, we retrieve the new state that is inside the server. And yeah, so we have match data in the constructor, and in the match data, we have the data property, and it is a byte array. So you just need to parse it by yourself. So for example, we are using UTF-8 to decode the byte array to a string, and then we just convert it to a JSON, and then we parse it using the matchState.fromJSON. So this is all the events that we receive from the backend. And also we have some dispatching events. So these are the events that are going to dispatch from the client to the server. And again, here we have a seal class, and here we have the 2 bytes property. And for example, this is for when we join the match. So we just have an empty implementation for 2 bytes. And also we have other dispatching events. For example, when you jump, you need to add your position, and for that we created a helper function that converts a JSON to bytes. So it is this one. It just converts the map that we have. It is a JSON. We're just converting it to the string, and then we just encode it using UTF-8. So this way we can have a byte array of our string that we have here. And after all, we have the match event OP codes, and let me explain it to you. So these are the numbers or operation codes that we contracted between the client and also the backend. For example, OP code 102 is for when the presences are updated. And yeah, so we have 2 functions, 2 helper functions to parse the incoming event and also the dispatching events. So here we have a switch case over the OP codes that we have, and we can just create the event that is related to the OP code. For example, for OP code match started, it is 103. We have match started event that we define in the match events. And yeah, we have the same for dispatching events. So for example, when we are dispatching player joined event, we are using the 200 OP code here, and so on and so forth for other ones. And yeah, so now let's implement some functions in our data source that we have. First of all, we need to have a WebSocket client. So the default client just works for the single call functions, not streams. But using the WebSocket client, we can listen to the events, or we can dispatch the match events or chat events or everything that is real time. So I'm gonna create a new Nakama WebSocket client using the init. And for host, I'm going to use the same that we have here. For SSL, I'm going to copy paste it here. And for token, yeah, so the point is that we need to have the token, session token here. That's why I put it here. And it is the token that we have. And as a result, we have WebSocket client. And yeah, so the point is that we need to have the token to establish the connection to the backend, the real-time connection. And to have the token, we need to initialize the session. So that's why we have the code here. And to have access to this connection in other methods that we have or functions that we have, I'm gonna create a late variable. The type is Nakama WebSocket client, and I'm going to initialize it here. And yeah, so now we are able to get access to the WebSocket client in other functions. And yeah, so now let's listen to the events that are coming from the backend. So I'm gonna define a new function. The name doesn't matter at the moment. And in the WebSocket client, we have on match data. Yeah, you see that we have a lot of streams here. For example, when we have a notification, when the party data is changed, or we have something for channels. And yeah, so now we need to use the unmatched data. So This is a string that just returns you some match data, and we need to map the data to the match event that we have. So let's change the type here to match event. So we are retrieving the match data that is coming from the Nakama, and we need to convert them to the match event that we already defined. And yeah, so now let's rename it to match data, and if you see, we have match data.op code. So using this, we can parse the message and send it back to the presentation layer. So we have a code for it. First of all, we try to find the OP code that we have in the match events. So as you remember, we have some codes here. We have OP code. For example, 100 is welcome, 103 is match started. And here we try to find the index of the OP code. And if we don't find it, we just throw an exception. And then we just get it using the values, because we have the index of the OP code that we just found. And then we use opcode.parse incoming event, and we just send the match data that we have. And if you remember, using this method, we have a switch case that we just try to parse the OP code that we have, and we return an event. So it's very simple. For example, if the OP code is match welcome, we just return the match welcome event. And in the presentation layer, we can just listen to the events, not the OP codes or anything that is related to the Nakama. And yeah, so we can just return it, and we can do it in a single line. And let's rename it to onMatch data. Okay, so now we can listen to the match data in our repository and then in our qubit. Okay, so let's find the multiplayer repository. Yeah, it's here, and we just need to add the onMatch event. OnMatch, yeah, so let's rename it to onMatch event because we will receive events here. Okay, so now we need to create a qubit for the multiplayer logic, and inside that we are going to listen to the match events. So I'm going to create a new qubit called multiplayer, and inside that we have a qubit. And yeah, so I have some code to copy paste here for the multiplayer state. I'm gonna explain it to you. So we have these properties. We have the match ID that we are working with. We have the join match loading. So this is for when you are trying to join a match. And this is for join match error. This is the current match that we are on. So it is a class that is from the Nakama. And we have the match state, that is something that we defined here. And we have match waiting remaining seconds. So this is something that we are gonna update in every second. Okay, so now we have the multiplayer state, and let's implement the qubit. I copy pasted the code, but I'm going to explain you. Okay, by the way, there's a function that is called join match, and we need it. I forgot to implement it in the data source and in the repository. And let's implement the function, and then I will get back to the qubit. So let's open the data source, and let's create a function called join match. And here we can say WebSocket client.join match. As you see, we have also join channel and join party, but we need to have join match, and as a result we have a match. We have a future of match. So let's have the match ID here, and we can directly call it to have the future of match. Okay, by the way, this is a class that is defined by the Nakama, and you have some properties such as match ID, is authoritative or not, label, size, and tick rate, and more. Okay, now we have the join match here, and let's implement it in the repository. Yeah, it's very simple. It has a parameter called match ID, and we just call the data source, and this is what we call in our qubit. So let's focus on the multiplayer qubit, and I'm gonna close everything. Yeah, so first of all, we have join match. So this is the function that we call when we open this page. So this is the first function that we call, and we say if the match is not the same as match ID that we already have. We just reset the state because it is a new match and we don't need to have the previous state anymore. And we say if we are already joining the match, so if it is in loading, we just return because we don't want to join on two matches at the same time. And here we just set the match loading to true, so we can show a loading here until we join the match, and we make the error empty, and we just save the match ID that we have here. And then we start listening to the match events because it is suggested by Nakama to listen on the events and then join the match. So this way you will receive all the events and nothing is missed. And also we just called the join match here. And then if it was successful, we just store it to the state that we have. And yeah, also we have some error handling. And yeah, so here, as I said, we are listening to the match events and we have this function. And here we just retrieve the match event that contains the new state that we have, and we just update the match state that we have in the multiplayer qubit or multiplayer state. And that's it. So this way we are updating the state that we have all the time that we receive a new event. But if we want to do a specific logic based on a specific event, we can have if else. For example, we can have if event is welcome event, show welcome message or something like that. Or we can also have the switch case over the event that we have, and for example this way we can write a specific logic for a specific events that we have here. But for now we just want to update the state and that's it. And the point is that we have a timer here in the constructor and the duration is 100 milliseconds, so it's running 10 times in a second. And we just call this function that refreshes the remaining time. And here, as you remember, we have a match runs at that is a timestamp for when the game is going to be run. And we just get the difference between the match runs at and the datetime.now, which is the current time, and we convert it to the seconds, and we just update the match waiting remaining seconds. And yeah, so now let's find this component to use the state.match waiting remaining seconds to show the timer here. So I think it was pending matchbox. Yeah, it's here. And let's wrap it with a block builder and use multiplayer qubit and multiplayer state. And let's import it. And instead of this time, we are going to use state.match waiting to a string. And yeah, so now we are showing the remaining seconds, but the point is that we need to call the join function somewhere. As you remember, we defined it in the qubit that we have, but we have never called it in any place. I'm going to change it to the page that we have here. Yeah, the multiplayer lobby page. I'm going to change it to stateful, and here we have an init state method, and I can use context.read to get access to the multiplayer qubit, and I can call the join match, and I'm going to use widget.matchID, which is the ID that we received from the backend. Yeah, okay, as you see, we have the timer now, and let me show you. I'm going to write a print statement in the match event. Yeah, so as you remember, when you join the match, you will receive the welcome event, and then you will receive the further events. Yeah, for example, we got the match welcome event, then we got the match presences update event, and then we got the match waiting time increased. So as you remember, it waits until we have enough players in the lobby. Okay, so now as you see, we have the timer, but to update the joined players, we need to filter the players that are in lobby. So as you remember, we have the new state and it contains all the players that are inside the match. And for example, each of them has a property called is in lobby. So we need to filter the players that are inside the lobby, and then we can show them inside the match. So to do that, I'm gonna create some properties here. At first, we need to store the user ID for the current user ID. This way we can realize whether we are joined in the list or not. So this is current user ID, and then we have a list of player state that is in lobby players, and then we have a boolean that is joined in lobby. So this is a flag that we set it true whenever we are joined in the lobby, and it is false whenever we are behind the lobby, so we are not joined yet. And let's define the default values. Okay, so now we define these three properties, and now we can update our onMatch event method. So we can just filter the players that are in lobby. As you see, we are iterating over the players, and we check if the player that is in lobby is true. We just add it to the in lobby players list, and we just set the state. And after that, we find in the in lobby players for any user ID that is the same as user ID that we have, it means that we are joined the lobby. So we can just disable the join button. Yeah, so we need to fill this property in the constructor. We can just add the game repository to have access to the user ID. So it's game repository, and here I'm gonna add it. And inside the constructor, let's have init function, and let's create a method. So I will move the timer logic to here, and also let's make it async, and here I can get the current user ID, and I will emit a new state that contains the current user ID. And yeah, so now we can use the joined in lobby flag to make the button disabled or enabled, and we can use the in lobby players to update the list. So let's find the widget. By the way, we have an error. Let's fix it. Okay, it needs to have the game repository. Yeah. And in the pending match box, I'm going to update this number, and I'm going to use state.inLobbyPlayers.length. And let's remove the constant here, and let's run the game to see what happens. Okay, it is 0. It is correct. And now we need to update the players that are in the list. Yeah, as you see, the item builder is here. So I'm going to use this one to get the length, and I'm going to use the in lobby players index.displayName. So let me have a variable here called player using this, and here we have the display name. And if we run it again, okay, so now as you see, we are in the lobby, and we see the players that are joined in the match. As you see, it's empty because no one is joined yet. And now we can implement the join functionality here. As you remember, we are in the match, but we are not in the lobby, and we need to implement the join function to dispatch an event to the backend. And let's open the Nakama data source. Okay, so we have a stream that is for the coming events, and now we need to have a function for dispatching events. So let me copy paste this function. Yes, as you see here, we have a send dispatching event that I just implemented, and we are calling the WebSocket client.send match data, and we need to enter the match ID here, and we need to set the OP code. So OP code is an integer. For example, you can set a number here, and as you see, we are trying to find the dispatching event that we are trying to send, and then we are trying to get the OP code from this function. So we have a switch case over the events that we have, and we just return the respective OP code that we have. And yeah, so now we can call it in the repository that we have in the multiplayer repository, and we can just use the same name. So let me copy paste it here, and we can just use Nakama data source dot send dispatching event. And let's import it, and it's a void method. Yeah, as you see here, it is defined as a void because you just send an event and you don't get anything in the response. It is a void function. Okay, now we can just write a function in our qubit that is, for example, join lobby, and we just can use multiplayer repository dot send dispatching event, and the match ID is the match ID that we have, and the event is dispatching player join the lobby event. Yeah, so here we just send the event, and now we can call this function whenever we click on the join button. So let's find it. Yeah, it's here, and we can have access to the qubit that we have, context.read, and here we can say multiplayer qubit, and we can call the join lobby, and that's it. So let's see what happens. Okay, so yeah, these are the events, and when I click here, nice. Yeah, you see that I just joined the lobby, and you see my player name here. So now let's run another instance of the app or the game in a Chrome browser. So this way we can compare them to see whether they can see each other or not. Okay, it is here, so let me click on the multiplayer. Yeah, as you see, this device can see the other device, and when I join here, you see that it just adds the other player here. And the point is that it doesn't have the display name yet, and in the next step we are going to implement a way to show the dash names that we have. So as you remember, we have some dashes here, and I'm gonna set these names as the default name for the players that are in the lobby. And also I'm gonna add the images to the game to show different colors for different players. So to do that, let me remove the web instance and let me move it back here. At first, let me import all the assets that we have. I'm going to add them inside the assets, images, inside the dashes. So as you see, I already added the SVG files. For example, this is the lime dash, this is peachy dash, this is sand dash, and yeah. So also I'm going to move the default dash here. So it is Flutter dash. Now let's define an enum to define our different type of dashes. So I'm going to define it here. Let's call it dash type. And I have a code here. So let me explain it to you. So as you see, we have 10 different kind of dashes, and here we have the asset name. So we just use the file name to retrieve the dash file. As you see, it's here. For example, rows dash is here, and we can have access to the assets, images, dashes, and the file name. And for example, it's here. And also we have the dash names. For example, we have lime dash, we have peachy dash, and this is something that we are going to show as a default instead of the profile here. And we have a special function here. So it returns a dash type based on the user ID that we have. So we just assign a new dash type for a new player based on the user ID that he or she has. For example, here we are iterating over the characters of the user ID, and then we sum the ASCII codes. So at the end we have a big number of integers. So it is sum of all the ASCII codes that the username has or user ID has. And then we have the mode operator here to just limit the number based on the length of the dash types that we have. And then we just return the index of the dashes that we have. So this way we are returning a dash type per player, and it is consistent in all the devices and in all the operating systems. And yeah, so now let's add some changes in the pending match box that we have. As you remember, we have dash player box, and let's add the user ID here, and it's here. And yeah, instead of showing the Flutter dash, we are going to get the dash type dot from user ID, and user ID is user ID. Okay, so we just need to get the asset name. Okay, so let's run to see what happens. We need to provide the user ID here, and let's run it again. Okay, so as you see, my dash color is this one, and also we need to update it here. So let me find wherever we are using Flutter dash.svg. So one of them is here inside the single player button. That's fine, we are using the Flutter Dash there. And we have profile overlay, that is this one, this widget. So here I'm going to get the user ID. I think we have it inside the game qubit and game state. So I think we have state dot current user account dot user dot ID. Yeah, this is the current user ID, and I'm going to use dash type dot from user ID, and this is the user ID that we have. What's the problem? Okay, we need to get the asset name. And also instead of the my profile, I'm going to show you the dash name here, but let me have a variable here called dash type to be able to reuse it here and here. Yeah, okay, and let me run it again. Yeah, so as you see, the color is fixed. By the way, we also need to change the text color here. So that's why I have the colors here. I'm going to copy it, and in the app colors, I'm going to paste them here. Yeah, so these are the colors that I got from the Figma design that I have, and you can just pass the dash type and you will get the color. So this way we can change the text color here. And yeah, so inside the profile overlay box, we can just update the text color. Is it this one? So let's change it to red, for example. Yeah, this is the correct one. And we can say app colors dot dash color, and the type is dash type. And let's run it. Yeah, so you see that the color is updated. And we need to do the same here. So you will see the name with the color of your dash. So it's inside the pending dash box, dash player box. And here we have the white color. I'm going to copy paste the code from here. And it is app colors. And the dash type is this one. So let's reuse it here and also here. And yeah, so the name is updated. And by the way, we need to have a stroke here. I'm gonna add it later. And let's run the Chrome instance to see whether everything is fine or not. Okay, so as you see here, we have the Scarlet Dash, and when we join, okay, we forgot to show the display name here. If the display name is empty, it is inside the dash player box. We have the player name, and we can say if it is empty, we can have the name here. If it is empty, use something else, otherwise the player name. And here we are going to use dash type dot name. So let's put it here to see what happens. Okay, so as you see, we have Imano here and Peachy Dash here. So let's see what happens inside the multiplayer. Okay, now we are showing the correct name. So let's add another instance to see whether it works or not. Okay, so we have two more instances here. I'm gonna resize it. And these are inside the lobby, but this one is not. And also this one. Yeah, so as you see here, we have 4 instances of the game running at the same time. And also here. Okay, so these two are inside the lobby, and let's add this one. As you see, it's inside the match. It can see the players, but when you click on the join button, it joins in the lobby and everyone can see the line dash. And also here we have the sand dash, and when you click on the join button, you see that it joins in the lobby, and it appears in all the systems that we have. And yeah, so now we can see everyone in the lobby, and the lobby is working well. And in the next step, we are going to implement the actual game. By the way, the code that we wrote today is not killing. I'm gonna make it better and I'm gonna commit it, then you can see it in the commit history. And yeah, so thanks for watching this video. Don't forget to hit the like and subscribe button. And in the next episode, we are going to implement the players inside the game. They can jump, they can gain a score, they can die, and so on and so forth. So have a nice day. Bye.